Welcome back, everyone. As you can see, we are on the sandstone flatland where it is perpetual nighttime, and that's because we've got another datapack video. This one's a little different. I actually wanted to show off how the copper wiring datapack works from a technical standpoint, since I've gotten a few requests for that. And I figured what better way to start this than just showing you this. This is how it works. And no, I'm not talking about the redstone block. I'm actually talking about what's on the redstone block, which is an invisible, no hitbox entity that doesn't even count in the F3 menu. It has no AI, can't ride or be ridden by other entities, and doesn't even have gravity. So what use is it exactly? You see, because the marker has little to no characteristics, we can have tens of thousands of them around us and we wouldn't even know, because they hardly make a performance difference. However, because they are still entities, we can actually use them to get relative positions and target things. And if you don't believe that there's an entity here, this command runs at every marker to summon particles. As you can see, there actually is one here. I wasn't joking. But it's okay if you didn't believe me, because these things have pretty much nothing for them, except for getting data tags that can be used to target them, and having an exact position and looking face direction for you to target things with them. And so with that in mind, let me just go ahead and power a copper bulb here. And as you can see, when I place a lightning rod, it'll also have this marker entity on it, and each one of them will. And I use these marker entities as a way to target these blocks and update them based on certain criteria. For example, these copper wires work by using the marker to detect if the current lightning rod is powered, and if so, it'll power the next one in the same direction. And of course, that one will detect if it's powered and then power the next one, and so on and so forth. And that's how we have a whole chain of these things. And the same thing goes for when they're unpowered. So if I break this, they'll all unpower in a sequence. It's just all happening at the same time, so it doesn't really look like a sequence. And then when these things encounter a block, they'll actually put a marker entity into the block, and each block has a different marker entity with a slightly different tag, so that I can easily separate them with behavior. And if you're wondering how these marker entities even come to be, the rods will actually summon an entity when you are looking at them, which I figured was a good way to implement this since you're looking at them when you place them. But as you can see, if I were to say, place one at the very corner right here, it won't light up. That's because I have to be just a little closer. I just have to look kind of towards the hitbox and it'll register. It's not perfect. Like if you're looking above, you have to be looking at the hitbox. But if you're looking below, then it can be a little more of a broad direction. It's definitely very weird, but it's at least consistent. And I figured, again, since you're going to be looking at these in order to place them, then you'll have no problem making sure these will all activate. And another thing to consider, although I can't really show it off right now, is that these things will activate in a sequence. So if there is no marker entity on this block, for instance, but there is here, then this one will put one here. And it won't duplicate any entities. It'll only put one there if there isn't one already. And so how I turn these regular decoration blocks into functional blocks is because there's a marker inside them, I use that to detect what block they're inside, and then I give them special behavior based on that. And so for example, the regular copper block, the copper grate, and the cut copper all work kind of the same way in that they use a scoreboard to detect how many powered inputs are going into them, and it will also detect how many outputs are going out, and if that score is 0, that means they're the same, which means power will go through. If that score is a negative number, it means there are more outputs than inputs, which means power won't go through. And if the number is positive, it means there are more inputs than outputs, which for the regular copper block means that you'll have power, and for the cut copper block, it means you won't. And so how the copper grate capacitor works is it simply checks the score of inputs, and it'll simply increase itself by that much every tick. And when it's full, it'll actually send output through to the other side because there doesn't need to be any charging. And like I said, these markers are used for everything in the data pack, including damaging you in survival when you touch these things, having the particle effects, and stuff like that. And so if you're curious about the exact code, I'll leave some screenshots on screen right here. You can just pause and take a look at it. Now, keep in mind, these are my actual functions that the game actually runs when you have this data pack. So the code might be looking a little messy, but this is literally what allows this data pack to work. So now that we've gotten that out of the way, I wanted to show you the creative and technical process for adding features into this pack so you can kind of get an idea of what goes into making it. And also one more thing I wanted to mention before I switch pages here is that if you're having problems with the data pack, having problems with these wires powering each other, if you upgraded from the previous version, so 1.0, and just directly imported 2.0, you're going to have to run the reset command, which is just function copper wire reset wire, which just kills all these entities so that they don't do anything. Because I did change the naming conventions for the sake of simplicity, so the old version entities will not work and you'll have to reset it. Hey, it's post-recording Aura here. Instead of just using the reset command, if you're upgrading from the previous version, you might just want to go ahead and break all the copper wires and the blocks associated. because the reset command itself has the new naming convention, so it doesn't really work. So yeah, just break all the blocks and you should be fine. But anyways, let's get into making something new. So the feature I'm thinking of adding in this video is going to be the insulated wires, which at first I thought, making honey because honeycombs work with copper would be kind of cool. But instead, I wanted to settle for using concrete because I figure concrete's very color coded. The color is very vibrant and it works as a sort of wire insulation slash coating. It kind of makes it look like a real life wire, which I think would be really cool. So for this to be functional, I'm seeing really three main steps. The first is activation, which is some sort of way to make the insulation appear. Then we have the visual side of things, which is, of course, making it appear right and just look right. And then, of course, the most important is the functionality, which is making sure the insulation works as it's supposed to. But for now, I'm going to worry about the visual and functional side of things because those are going to be a lot more challenging. Now, as for the visual change, I already made a block display in this command block here, which summons at the specific coordinates, that is the center of this block here, and that'll just represent that the marker will summon it at its own relative position. And it's got some custom scaling, so let me just show off what this looks like. This is going to be kind of what the wire looks like. It's relatively big. It's about as wide as a flower pot in the center of the block, and it'll encompass the whole block. But as you can see, we've got a little issue right now, and that is that this has a Z-fighting, as it's sometimes called, where these textures are overlapping each other because they both occupy the same exact height. And this is also true on the bottom side, that you don't see this as much. And so a way to potentially solve this is to offset this wire slightly so that these two aren't fighting. All right, I changed the height of the block display and now it is offset. As you can see, this little bit of the wire is exposed, which I actually think is kind of cool because that'll be really cool for some aesthetic builds. And although it does lower it down here, you don't actually see this since this is, inside a block, so it shouldn't be a problem. And as you can see, when I place a second block here and I activate it again, it will do the exact same thing. So these two aren't culling with each other because they're not actually touching. If I go into spectator mode, you can see that they are not overlapping at all, which is really important. Okay, we have our wires, at least when they're going up and down. I'll worry about the other directions later because that's a whole different set of sizes with the block and shape and all that. Now, another thing I'm seeing that I can run into is the fact that if there's a solid block here, especially if there were to be a copper block that we use for functional purposes, there's a bit of a wire sort of showing over here. So I think my next solution is going to be with these block displays detecting if the block above them is not a lightning rod and not air, because obviously with a lightning rod it'll still be offset down slightly. And then if the block is a solid block, then it will actually stretch this last one up one more pixel so that it matches. So if I'm able to do that, then this should just stretch all the way and it won't look too distorted because it'll just be a slight stretch, so it shouldn't be a big deal. All right, so I added another data pack right here, which is a repeating command that executes at the block display, and it detects if the block above it, since we're just going up and down for now, is not air and is not another lightning rod, and if so, it will change its scale so that it fills all the way. So if this works correctly, yeah, there we go. Okay, yeah, so that just simply fills. Now, obviously, it does just stay filled, so I'm going to have to do the opposite check with another couple of command blocks, and then if that condition is not true, it'll shrink back down. So let me just do that real quick. All right, so I think I made it work. So if you put a block up here, then it will fill, and then if it's air or another lightning rod, then it won't. Good. So this is already looking pretty good. We've got a functional wire that will clip to the nearest block if there is one, and it won't if there isn't. So going back to the previous step, now what we're going to do is actually make sure these can activate and deactivate properly. So even though I'm going to use a right-click detection method for this to work, for now I'm just going to use a drop method, which just means I'm going to be dropping a certain item, and then it'll detect that item and add this. And that's just easier to do now. Obviously, I'll change it later, so let's go ahead and do that real quick. What we're going to do is just simply execute at an item at its own current location, and then give it an if, which is if the current block is a lightning rod. And just for this sake, we're going to make sure it's facing up so that we don't have extra stuff going on. After that, we're going to do an unless statement so that we don't get any duplicate entities, and we're just going to make sure there is no block display here. And then if that's the case, then we will go ahead and summon this block display, and I'm just going to grab this command here, so that we can just use this one. So once we set this to a repeat command, then we should just be able to create more of these by just dropping an item. And just like that, we've gotten our first bug, which is that it actually centers on the location of the item itself. Now, luckily, it doesn't create any display entity duplicates, but it seems to actually create some more at very specific angles, which is kind of funny, actually. All right, so I changed it so now the marker itself that's going to be within this lightning rod will actually summon it, and it didn't summon it. Okay, that's fun. Okay, so it should work now, and yeah, there we go. Now it actually creates the wire. If I place another one up here and just drop another item on it, it'll also create the wire. So we've got a basic activation method here. Now, one thing to consider with this activation method is that if we delete these, the block displays stay. So now what we've got to do is make sure these block displays get removed if the block that they're supposed to be on does not exist. All right, so we've added another command block, and this one just simply targets the block display, and unless the current block that it's at is a lightning rod, it will kill itself. So very rudimentary, but again, this is just a test to make sure everything works, and once we actually translate this to the data pack, things will be a lot more specific. We'll have tags, we'll have exact blocks, etc., etc. But now, if we give ourselves the little block display here and we get rid of this block, the block display will also go away. Now that means we no longer need this command block, as it will just work anywhere. And it's honestly really good already. I'm happy that this is working so far. Now obviously we're going to have to kill the item once the block display appears, and then when you get rid of the block, the item will be given back, in the case it's concrete, so that way you actually, don't waste the item just because you accidentally drop it or whatever. But for now, we've got a basic system in place. So these two activate, these two give a little display change. Now the hardest part is going to actually be to make sure this functions correctly. You see, the challenge and the big thing I didn't want to have to worry about is that when these are powered, they power adjacent blocks. That's true whether or not they have insulation around them, because that's just a factor of Minecraft and you can't change that. But that doesn't really sell the effect for insulation, as this would normally block electricity. So we need to make sure this does not power adjacent blocks. And unfortunately, the only way to do that is to have these not be powered at all when they are in insulation. Which, in all fairness, you wouldn't be able to tell if they were powered, since the insulation's actually blocking them unless you don't have this block here. But I'm sure you can settle with just having this not be powered in the off chance that you have an exposed wire. Now I can go ahead and make sure the sparks still happen when it is quote-unquote powered by insulation, but the bigger concern is how we are going to make this entire data pack work. Because after all, the entire data pack and all of the features in it hinder upon these blocks being powered and detecting that they are powered and then doing things based on that powered state. So essentially, we're going to have to come up with a new way for these things to be considered powered without actually having their powered state, which means we're going to have to assign tags to the entities and do entity tag checks rather than just block checks, which definitely takes more resources to do. But in this case, if you want to use insulation, then you're just going to have to go with the more resource intensive method. So my idea for this is going to be that it will not power the actual block itself if there's insulation around it, which is just simply if there is the block display around it. And instead, it will give it a tag, like tag equals powered or something like that, which will indicate that these have a technical powered state. And then any functional blocks that rely on these things being powered will just have an additional detection for the powered state. So I got straight to work. The first thing I did was I changed all of these execute commands to be positioned over. Since I can't detect the block, I have to be positioned at the block so that I can just detect a small distance with the entities. And I'm aware that these three documents have sort of the same commands. I should have just combined them as an optimization form so I wouldn't have as many commands, but I'll do that later. After that, what I did is I changed the requirements for these detections, which is going to rely on the entity and its powered tag. And so then I had to change all of these other execute commands for the positions and the entity requirements. And because of that, I was able to get rid of the block requirements. So now it just simply uses the lightning rod's direction face, and then it relies on the powered state based on the entity. And then after that, I also changed the set block commands, since all I would be doing is just changing the tag state based on certain requirements, and that way the whole thing sort of balanced out and it all made sense. Okay, so I think after about an hour or so, I'm gonna guess, of making this stuff, I think I got it to work right. So if you add an item here, then the rods will still be powered. That's just something I haven't fixed yet. But if you were to place one that wouldn't become powered and you create the little insulation here, then when it is powered, you don't actually have the insulation. However, this is still considered powered as it will power these other blocks. If we power this here and place a block here, then this should be considered powered. Okay, not yet, but we're definitely getting somewhere, I think. Because this is a power source, and obviously if this one's powered, then it'll work properly. No? No? Okay. Yep, that would be it. Yeah. Let me just do that. All right, now it should work. Okay, yeah, there we go. So if I do this, then it should also work. Yeah, okay. All right, it works as it's supposed to. Check that out. Look at that. Look at that. Isn't that cool or what? I made it work. I managed to make it work. That took a very long time and a lot of typos. Now, as per usual, the copper grate's giving us problems. It doesn't look like it's charging, but I might have just not coded that. And also, we got the culling issue again, so we got to fix that. For now, at the very least, this is working regardless of which one of these you use, which is honestly really impressive. I genuinely didn't think it would. For now, this has kind of been the process of how I add features. Obviously, this is a very scuffed version. In the official update, this will be working properly. All the sides will work, not just on top, and you can do any color, and the mechanic in which to activate them won't be dropping any item. It'll be dropping the specific item or not even dropping at all. And, you know, a few of the other quirks, but that's been kind of my process and how I make these things. It's a bunch of trial and error. Now, there's one more thing I want to mention, and that's for the creative process itself, and something I learned over the years of making data packs and also just making stuff in general. And that is that organize your thoughts and organize the process and problem solve before you get into something. If you have a lot of easy things you can do those first, as long as they kind of follow the same sequence like I was doing here. And when it comes to the harder stuff, just skip it and kind of put it off to the side and do it later, because that way you preserve your flow state. That way you preserve the momentum you got going on of doing the easier stuff first. And then when you're done with all the easy stuff, you have a full list of other things to get to at another time. And that guarantees that you're not burnt out because you get stuck on the wrong things and you lose your momentum, so to speak. And it also helps you avoid getting off track, because for a lot of creative people, that's very, very easy. So after taking a short break and going outside to play with my dog, and then getting in some of that premium quality grass touching, hooray! I got right back to work. So the first thing I did was to make sure that the chiseled copper blocks worked the same way as the other ones, which mostly was just changing coordinates the same way I did before. So you're going to see a lot of that, and of course the entity checks as well. And after confirming that the chiseled copper indeed worked, I did a little celebratory head nod, and then I went back to the copper grate. I used pigs as a detection method to make sure things were working, and as you can see, things were definitely working. So after fixing that detection, I had a weird bug with the display of the copper grate. And so after a bit of tweaking with the commands, I managed to make the copper grate actually work properly and display properly, which I was pretty happy about. After that, I started making the displays for all the wires in all directions, which first started with them going straight up. Then they started doing this, and then that, which was also a little off. And then finally, I managed to make them not appear at all, and they were actually inside the block. It was very weird. Block display entities, they're not fun to mess with, but I finally got it working, which was pretty good, and I was excited because this was now really shaping up to be how I wanted it to turn out. So after fixing a few display errors and making sure these only damaged you when they were not insulated, I then incorporated the drop mechanic properly by allowing the exact block you drop to be limited to concrete and also to be put on the wires as insulation. Originally, this was going to be a right-click detection using food, but because of the different versions of 1.21, that made things weird because they kind of changed how they worked, so I just kept it as a drop mechanic instead. And then finally, at the very end, I made sure that the item itself would actually be deleted when you drop it onto the wire, and if you break it, it will also give you the item back. So as you can see, if I break these items, then the item came back, so you don't lose anything. And at this point, it was pretty polished. Yeah, it wasn't perfectly optimized, but I at least made a pretty good system. Anyways, so that was the process. This feature now exists, and yeah, I gotta optimize it and polish it up a bit, fix a few glitches that I probably unintentionally created, but at the very least, that's sort of how I add features, and this is true for any data pack I make. It's a lot of trial and error, a lot of just finding issues with your code and fixing it and optimizing it later, and a bunch of stuff like that. So anyway, if you did enjoy, be sure to leave a like. I appreciate that you stuck around for the entire ride, and as a treat, I want to show you a little development thing I'm working on for another data pack. So this one uses the elytra, let me put that on real quick. I actually have another one right here because I was testing with it. And let me get up to a high space real quick. All right, so I should be high enough. Now if I glide, you'll see that there's a little bar at the bottom. And if I sort of just descend a little bit and press crouch, then I flap and I actually get most of my height back. Yeah, this new data pack that I'm working on, at least with the elytra, adds the ability to flap your wings, and you actually preserve your height pretty well. And so you don't need fireworks as much. I feel like elytras should have some kind of wing flapping mechanics, so I added one and it works pretty well. So there was a little sneak peek. I don't know when that data pack's coming out, but I do know that the next video will be, like I said, for the update to this one. So anyway, I'll see you all next time.